For years, SpaceX focused on building a city on Mars, but hitting that target would take at least 20 years of incredibly dangerous work. And Elon Musk has admitted the chances of survival are slim. This has led to a quiet pivot. The current plan centers on a 10-year timeline to build a self-growing city on the moon, where if something goes wrong, the trip home is actually possible. Of course, a self-growing city sounds like science fiction. It is the kind of highly provocative, purposefully vague terminology Musk uses to grab headlines, while keeping the actual mechanics open to interpretation. Details emerging through Musk's AI company, xAI, suggest this lunar city functions as an industrial manufacturing hub. Its specific purpose is to fabricate satellites equipped with massive data centers, which will then launch into orbit to run super advanced AI models for Earth. Going to the moon is a dedicated logistics strategy. SpaceX is attempting to solve the physical bottlenecks that currently block the infrastructure required for the future of artificial intelligence. To understand why they have to leave the planet, you have to look at the math of launching hardware into space. Getting heavy, massive AI satellites off the ground requires overcoming Earth's immense gravity and punching through a thick, resistant atmosphere. This chart shows the massive volume of fuel and energy required to hit Earth's escape velocity. Escape velocity is the exact speed required for an object to break free from a planet's gravitational pull. Down here, that speed is 11.2 kilometers per second. Hitting that number requires giant rockets, burning thousands of tons of combustible fuel for every single launch. But the moon is much smaller and has zero atmosphere to create wind resistance. Its escape velocity drops to just 2.38 kilometers per second. Moving heavy manufacturing 238,000 miles away is a mathematical gravity hack. SpaceX is bypassing the financial toll of Earth's physics by relocating the heaviest part of the assembly line to a low-gravity zone. The Apollo missions provide a baseline for how difficult it is to move hardware to the lunar surface. The Saturn V remains one of the most powerful machines humans have ever built. Yet for all that towering scale and millions of pounds of thrust, only a fraction of the weight made it to the surface, a fragile module big enough to keep 2 astronauts alive for 3 days. That equation changes with SpaceX's Starship. It is a fully reusable, super heavy lift rocket designed specifically to haul massive volumes of industrial cargo and land safely on other worlds. Starship also has a secondary, vital function. Once it lands on the moon and the cargo is unloaded, what remains is an empty stainless steel tube 9 meters wide and 60 meters long. Standing alone, 3 millimeters of steel cannot protect against the environment outside. Automated machines will bury the empty hull beneath lunar soil, creating heavy-duty insulation against violent temperature swings, radiation, and meteorites. By repurposing the delivery vehicle itself, SpaceX immediately clears the biggest hurdle of off-world survival. Just one buried Starship provides an internal pressurized volume equivalent to the entire International Space Station. Humans in pressurized suits lack the dexterity to construct heavy industrial factories. To make this work, an automated mechanical workforce is mandatory. This is a flowchart illustrating the concept of a von Neumann probe. A von Neumann probe is a theoretical machine designed to land on a planet, harvest raw materials, construct a factory, and produce exact copies of itself without any human intervention. SpaceX intends to make that theory a physical reality using Optimus, the humanoid robot from Tesla. These machines are being programmed to step off the Starship, mine ore, forge metal, and fabricate microchips autonomously. To connect the mines to the factories, Tesla is supplying the logistics network. They are adapting the heavy stainless steel architecture of the Cybertruck into an autonomous AI-driven fleet of lunar rovers, capable of hauling massive loads. Compare that enclosed, intelligent automation to the exposed dune buggies of the 1970s. Those Apollo rovers were marvels of their era, but they were limited by non-rechargeable batteries and a maximum driving range of under 100 kilometers. Integrating Tesla's AI driving software with a robotic labor force creates a closed-loop system. It removes the most expensive and resource-heavy variable from the manufacturing equation: human beings. Operating an automated factory that builds artificial intelligence satellites requires an enormous amount of energy. To supply it, Musk has directed his companies to manufacture 100 gigawatts of space-grade solar panels annually in the United States. These panels will be radically stripped down. Because the moon lacks wind, rain, and weather patterns, the heavy glass and metal casing we use on Earth is unnecessary. All of that harvested electricity feeds the final piece of the lunar supply chain, the export mechanism. SpaceX won't use rockets to send their new AI satellites into Earth orbit. They're going to use a mass driver. A mass driver is a massive railgun that uses powerful electromagnets to accelerate objects down a steel track. It flings the payload right off the surface, utilizing the low lunar escape velocity. Combining weatherless solar arrays with an electromagnetic launch system creates a permanent, infinite export loop. It relies solely on magnets, metal, and sunlight, requiring zero combustible fuel. The corporate entities of xAI, SpaceX, and Tesla represent modular components of a single industrial engine. Software, logistics, and robotics are being integrated into one unified strategy. This graphic illustrates exactly what Musk means when he talks about creating amazing abundance. It is a strict economic equation. Reusable heavy transport, plus an automated robotic workforce, plus infinite solar energy equals near-zero cost manufacturing. When the cost of labor and the energy required to forge steel drop towards zero, physical limits disappear. Humanity becomes restricted only by our ability to invent, rather than our access to resources. The moon, in this context, is the testing ground. It is the closest, safest place to prove that an autonomous, closed-loop industrial base actually functions. Successfully mining, refining, and exporting hardware on the lunar surface proves the viability of this automated industrial model. Once verified, this system can be duplicated and scaled across the solar system, making the colonization of Mars an inevitable physical reality.